I hope you'll go along with this rather unusual setting and the fact that I remain seated when I get introduced and the fact that I'm going to come to you mostly through this medium here for the rest of the show. And I should tell you that I'm backed up by quite a staff of people between here and Menlo Park, where Stanford Research is located, some 30 miles south of here. And if every one of us does our job well, it'll all go very interesting, I think. The research program that I'm going to describe to you is quickly characterizable by saying, if in your office you as an intellectual worker were supplied with a computer display backed up by a computer that was alive for you all day and was instantly responsive, instantly responsive to every action you had, how much value could you derive from that? Well, this basically characterizes what we've been pursuing for many years in what we call the Augmented Human Intellect Research Center at Stanford Research Institute. Now, the whole session is going to be devoted to trying to describe and present to you the nature of this program, but unfortunately, or fortunately, the products of this program, the technology of it, lends itself well to an interesting way to portray it for you. So we're going to try our best to show you rather than tell you about this program. A very essential part of what we have developed technologically is what does come through this display to us. And I'm going to start out without telling you very much about the program and just run through a little bit of the action that this provides us. So in my office, I have a console like this, and there are 12 others that are computer supplies, and we try nowadays to do our daily work on here. So this characterizes the way I could sit here and look at a completely blank piece of paper. That's the way I start many projects. So with my system, that's a good start. I'll sit here and say, I'd like to load that in. So, very sorry about that. So I'm putting in an entity called a statement, and that's full of other entities called words. And if I make some mistakes, I can back up a little bit. So I have a statement with some entities' words, and I can do some operations on these. I can copy a word. I can say that word like copy after itself. In fact, that pair of words I'd like to copy after itself, and I can just do this a few times and get a bit of material there. And there are other entities like text. Say after there, I'd like to copy from that entity point to that point, and it'll copy it. Great. So I could get myself some material on my blank piece of paper, and then I'd say, well, this is going to be more important than it looks. So I'd like to set up a file. So I tell the machine, all right, output to a file. And it says, oh, I need a name. I'll give it a name. I'll say it's sample file. And I'll say, please output it. It says it did. And then it comes back automatically with an origin statement or header telling me the name of the file and the date and the time and who established it. And thereafter, I can always do something. I can ask for the status of a file, and it'll tell me that information. Very small file now, owned by me, last written by me very shortly ago, etc., and other interesting data in there. So we've seen how we can start with a blank piece of paper and go to developing a file. This file is one statement with a few words in it. Let's make more statements. I'll say copy that statement, and lo and behold, I have another one. Copy that one, another one. I can even copy groups of statements. I can say after that one, copy the group from there to there. And it does. I can look at that and say, probably goes off the screen. It'd be interesting if I could ask the computer to collapse that, perhaps to show me just the first line of each of those statements. All right, please do that. So it did. This is one aspect of what we'll use over and over again through this presentation, what we call view control, where no matter where in the file we're looking, we can ask it to use any one of a large number of parameters for constructing a view at that point in the file that best suits our need at the time. This one wants us to give an overview of the thing. So I'll say, well, I have this. I don't want them all to be statement 1, so I'll just replace the word there with a 2. And how about that one with a 3? It's just a place to forget how to count. So I can look and say, all right, got statements 1, 2, 3, and 4. If I'd like to make them a little prettier, I can, I can go to work and neaten them up a little, but that isn't what I always do. Oops. You can tell that I have not warmed up yet. I hope you can tell. Right, all right. So I can get it lined up, and I can say, for instance, other entities like an invisible string. I don't know whether that's tabs or characters in there, but I can say if I want to replace that invisible string with just one character, not that character, that one, space, and it'll do it. So I can look at that and say I have files 1, 2, 3, 4, 5, 6, and I've named them that way. But that's usually a sort of a pain to do that. So I'll ask it to number them themselves. And one of the views is such that it will give you a list numbering for each of those statements. And I can also open them all up or ask them without numbers, however I wish, and then I can output them. So we've seen ways to work fairly fast with the entities of a statement in a file, create a file. I can delete that file or mess it up considerably. Like if I'm going to say I want to delete that word, but I accidentally hit that entity instead, watch what happens. It sort of replaces the whole thing with nothing. That occasionally happens, so you say, all right, I'll load that file. And it'll come back in as it was. I last saved it, telling me the date that I wrote it. And unfortunately, I didn't save enough. Well, I'm through with this example right now. Let me go to a file that I prepared just after my wife called me and said, on the way home, would you do a little shopping for me? So as soon as she said that, I got my system organized. And made a shopping list. So it's got quite a few items on it, and if I want to, I can see that, yes, those are numbered statements. And I can say there are ways I can scan down it, like I can point to 10 and say put it at the top, and I scan up and point to 23, and I got quite a few. And I remember that's about as far as it got when she said, well, call me back when you're ready to go shopping and I'll tell you the rest of the things. So let me jump back to the head of the list, and I can do things like begin to reorganize it a little bit. Well, I say after bananas, it's more likely that I'll take the carrots there. And so carrots moved right up behind bananas, and aspirin doesn't really belong there. I think aspirin goes after paper towels in the order. Well, pretty soon I would begin to have a lot of trouble keeping that straight. So let me organize it by saying just generally produce. What the hell happened to it? All right, I'm going to try it until I enter a statement that says, hey, that's what I'm doing. Try there. I suspect that something's going wrong, and I would call up the programmer or the hardware man and tell him, I made it. Produce. I really haven't warmed up to this thing yet. So I'll say, well, produce, I'll categorize things. Let me look at it that way, and I'll say, let me move a statement for produce carrots, and I'd like to subcategorizing it. So it moved. And there it is. I go, oh, that's what happened. All right, produce, I've got carrots, and I'll move under there also bananas. And in fact, I could move a whole group under there, saying oranges and apples also. So I can begin categorizing things like that, and if I looked at the numbers now, I'd find that these items fit under there as a subset, and I realize I can categorize quite extensively. I could introduce a new thing under there that was something I just invented, a skinless banana, but I have to go there and look at it. So part of our view control, besides this thing we've shown you of showing numbers or not, is also whether we can show you some of these different levels or not. I can say I only want to see 2 levels. or only one level deep in there. It makes it very nice for studying it. Or I can do something like when I say, let's put produce at the top, let's open up one level below it and only show me what's below it. And then another level if I wish, and then no numbers. So these moving around with jump to identities, there are many ways to move around and to make views, and this is one of the basic features of this tool we have. Well, suppose I worked for some time at this and then call up my wife to get the rest of the list. I'd eventually end up with a whole structure where I could say, gee, there were a lot of things. A market, shoe store I have to stop to. Let me see what I was supposed to get in the market. Oh, produce, cans, cereals. What about cereals? Oh, cereals, bread, noodles, like that. Okay. Back up there, if I want to look at the numbers, that's what I can. If I want to open up everything, see that, or many lines. There are many ways in which I can look at that. And but one interesting thing here that I haven't told you about is that when the numbers are on, I can do something like, say, instead of jump to identity and pointing to that and having it bring to the top, or jumping return back, I can say I jump to a name and say go to 2A4. And it'll do it. Or return. So I can jump to a location number just by giving it, or if I wish, I can add it as text in there and say jump to name and just point to that and it'll go to 2A. Did I say that? Carrots, right? Right, carrots, 2A4. So I gave it the name of that, can go to it. I can give it the names of, I don't want to go that word, that one. I could say go to 1, which is out of sight from here now, and say jump to that. And I'm at 1, different views. So it's very easy to jump around and make cross-references. It turns out if I wish, I can also make a cross-reference to something where I gave it a label or a name, such as you do when you're programming. I can call this alpha. I can say jump to name, and I can type it. I think I made a mistake when I type it. So what I should really do is say I'd like to reconform my whole picture. So there, it's going to say jump to name. And I jump to something named alpha there. All right, so I can give names, and I can say in here, a reference like that, or I can say jump to name and point to that, and lo and behold, I'll go to this thing that was I'd named alpha. So I can name it, and if I want to, I can ask to see the name, or I can ask not to see the names, depending on which. Right now we happen not to be seeing the names. So look what else we can do in here. I've got this file that's structured. If I want to see what's in there, I can walk down the hierarchy levels and see, or return. But there's another thing I can do. There's a root I said I have here. So here, I'm afraid I'll need a different picture of the view. So here's what I drew with a picture drawing capability here. It's a slight map if I start from work, and here's the route I seem to have to go to pick up all the materials. And that's my plan for getting home tonight. But if I want to, I can say, the library, what am I supposed to pick up there? I can just point to that, and oh, I see, overdue books and all. Well, there was a statement there with that name on it. Go back. What am I supposed to pick up at the drugstore? I see, very interesting. All right. Market? Oh, I've already seen that. Produce and all like that. Gee, that's too much. Anyway, so we have this feature of structuring our material hierarchically, being able to move around it very well. when we get a hierarchy, such as I can show you here now, I can do things if I want to just say, I'd like to interchange produce and canned materials. Bingo. And they're all numbered rightly if I care to look. Interchanging them very quickly. Cans are going to get interchanged with produce. They do it and all gets renumbered. So I have ways of studying over, making different views, moving around, going to specified points, and modifying the structure. At the same time, I've seen that I have a repertoire of different entities, like character, knock off that character, replace the character, make that P. So I have entities of all sorts that I can say I want to do operations on, and this basic structure that I can move over and study and get about very quickly. So that is the essence now. That's the essence of the tool we have. There are a lot of details that I've left out for you. And now I'd like to stop a minute and just make sure you understand we're shifting from illustrative material to the real working stuff, in case you wouldn't recognize it otherwise. We've used this tool to do our daily work, and our system has been built, this time-sharing system, for about 6 months now. It's been working. And in that time, we've gone from getting one console to getting about 6 working now, with 6 more due the rest of spring. This is our 4th computer in which we've had this kind of a system, so we've learned a lot about the user features we want and how to be fairly skillful. But this next step about learning how, when you're faced with having this in your office all day, as I now do, in a very exciting sense, how do you put that to work for yourself? How do you organize your files? What kind of things do you do? So to get going on this, let's switch away from the tool we have here and talk about some of the general features of the program, some of the ways it's built, and get back a little later to the nature of our usage of it. All right, let me get back to this material. Here's just the outline I'm going to use. You can realize that it's a file. These are statements, and we're probably looking at the top level of them. In the first one, the introduction, you can consider we've done. In the next one, overall about program, is what I'm going to do now. Well, I'm going to do something called jump on a link. And a link is something that'll go between files. So what it's going to do, it says I'm going to go to your file name CNRO. And the link also says where in that file and just what view it wants. So when I do like that, I'm in the middle of that other file looking at this particular material that's been carved out by the specifications on that link. And this is telling me to make a preparation to start out on a presentation. But I should also remember I'm going back to this other file because what I want to do is restore a different kind of look. All right. Oops. I had to go to a different file in which, because I made a hitch in my rehearsing for this thing, in which I have many types of format structures set up and numbered, and I just reset the kind that I want to use to show you this material. We're very flexible with it. For instance, I can say I'd like to restore number 7 is a horrible example. See, I can have many ways in which I can control all of the parameters, character size, spacing, location, and everything else, but I don't usually go to this extreme, but it's just showing you that I can. The one I want right now is the one that shows you a simple large view. We usually work with a view, wait a minute. We usually work with something like this, where when we're working with our close basis, we can do quite well, but it's felt that that would be a little hard for people to see, so we're using it like this, where we don't see as much material, but they're larger and clearer. So now let me go back to that file I came here from, and say, all right, now I'm ready. I'd like to jump and learn about the program. When I get in here now, it looks different, as it should. This is another file, and in this file I prepared a chain of views. And using some of the tools, I have it all set so I can go from one scene to the other. I could study them in the fashion I've shown you before, but it's sort of fun to set up these chains, and it represents to you a way in which we work too. So to do it, I'm going to freeze a statement that's named A, and I'm going to put on a certain parameter when I do it. And then I'm going to jump to a link. And here's a link. It says you want to go to statement A, but after the colon, all this garbage tells a bunch of abbreviated ways in which you'd like to control the view when you get there. Many parameters, as you'll notice. So I'll just say, all right, go to that one, and I'm looking at statement A. Now it's telling me this presentation is devoted to the HIRC. The natural question is, what's that? Aha. That was another boo-boo I made. I left several statements frozen. This statement I've asked to be frozen. That was the setup operation. It's just going to stay there above that dotted line as the viewing part of my screen from there down jumps around on the links I have set up. Okay, the first jump took me to this statement saying, all right, Augmented Human Intellect Research Center is what HIRC stands for. A hidden link will take me to the next one, telling you where it's located, that in SRI, it's an explicit organizational entity at what we call a group level. But also I'd like to point out there are other man-computer work going on at SRI, and ours is but one. So if I jump on a link, incidentally, I should just stop and reveal to you that the link is hidden under there. I was very clever to set the viewing parameters so they wouldn't show the link, but when I say jump to link and mark it there, the computer goes looking from there on for that link and obeys it. And I'm not showing the statement names either, but this is statement named B, obviously. So that program involves about 17 people together with the special laboratory facilities we have. It's sponsored by government agencies exclusively, ARPA, NASA, and RIDC now, and in the past, AFOSR and ESD, and these were the people that first grub-staked us many years ago. All right, and it's been a goal-oriented pursuit for many years, and I think we can just go off and get a quick little picture I sketched to show this is the staffing over the years from 1950 on, and it's had slightly bumpy history. During these years, there was only one of us. I go back to where I was and say, let's continue on in this file. That link took me out to a different file, to a statement for that view, and I jump back to this file where I was, and now within this file I make a link to another to say, the HIRC is pursuing these goals. Basic goal, improve the effectiveness with which individuals and organizations work at intellectual tasks. What does their effectiveness involve then? Better solutions, faster solutions, solutions to more complex problems, with better use of human capabilities. Really thinking about that. But a corollary goal is, besides improving the effectiveness, to develop a system-oriented discipline for designing the means by which greater effectiveness is achieved. That's very important to us. The approach for this should result in the system-oriented discipline. Let me just show you how I constructed this file. You notice underneath there with that and that, there was just a link hidden here that went back to this view with a slightly different view parameters. To give you that view. All right, there's another one hidden there. It says the general approach for us, empirical. We're pursuing this monstrous goal, monstrously difficult, by building and trying empirically. And we're approaching it evolutionary-wise because we feel that it's a whole system problem. You need to get a person in that environment working and looking at the many aspects of his working system that are involved in his effectiveness. That's many more things than just these computer-aided tools. In a large system like that, we need to do it evolutionary-wise because we can't be analytic enough about it at any one point to decide what best our next thing should be. We can only decide from here, as well as we can analyze it, where we can invest our next resources to get the most return at an increase of the effectiveness of the system we have. And this item down here is the term bootstrapping applied in a slightly new sense. We're applying that to our approach, where we're saying we need a research subject group to give them these tools, put them to work with them, study them, and improve them. We'll do that by making ourselves be the subject group and studying ourselves and making the tools so that they improve our ability to develop and study these kinds of systems and to produce, in the end, this kind of system discipline. So it's a struggle doing it that way, but it's beginning to pay off. All right, from there. Sorry. I'm apologizing to my friend, the computer. I said, jump to link and hit it up here. And it went and found these parentheses starting here and says, that's not a link. I should have hit it here and it'll find a real link. And I'm back in this list here. And I've given you an overall picture about the program. And that's out of the way, and I can just move my marker down and say, let's save that version. So this tool, in pursuing those goals, one of our principal tools is this computer aid system. Let's talk about it as a system. There's a link sequence to jump in there too, where we talk about NLS, meaning online system, a very general term. It's going to be NLS for many, many years, an online system that will evolve. Right now we consider it to be primarily an instrument and a vehicle for helping humans to operate within the domain of complex information structures. Well, what do we mean by operate? Well, compose, study, modify is the place we started now. We know there are many other analytic things you could do, but we want to get around, study, and modify. And then to further information about what does complex structure mean, we're talking about complex structure and emphasizing structure because we say, although the content represents your concepts, there's a structural relationship between that content entities that should represent the relationship between the concepts of human thought. All right, we never can do that very well with linear text. So inside the computer we can represent that quite well. In fact, we can represent information structures in a computer that would generally be far too complex for you to study directly. But NLS serves as a tool to roam over that, navigate through a complex structure, be able to find your way and be navigating, move about it rapidly, and be able to see what you want to see at any given point. That's how we think of NLS as a tool. All right, these are all very important concepts to us because these, together with the bootstrapping, have told us where to start. We start by building an instrument that we can sit at and work during our day to organize the kind of working information we need as a task force developing systems. We need to write our specifications, our plans, our programs, our users' guides, our documentation, our reports, and even our proposals. So we've been using these. Let me return back here and said I've finished that version, and to help you keep track of where we are, and a little bit to help me too, we'll move that down. So having gone through these items, I'd like to come in now and begin to telling you something about the implementation. So I'm going to open up under here and talk to you about the control techniques, control devices, control dialogue, and control meta-language that we're using. Okay, to talk about control devices, we'll use this overhead camera shot where you can see the devices that I'm using. I use 3, and they're not all standard. We have a pointing device called our mouse, a standard keyboard, and a special key set we have here. And we're going to go for a picture down in our laboratory in Menlo Park and pipe it up that'll show you from another point of view more about how that mouse works. Come in, Menlo Park. Okay, there's Don Andrews' hand in Menlo Park. And in a second we'll see the screen that he's working and the way the tracking spot moves in conjunction with movements of that mouse. I don't know why we call it a mouse. Sometimes I apologize. It started that way, and we never did change it. All right. As it moves up or down or sideways, so does the tracking spot. And the principles for its operation are quite easy to see. If you'll turn it over, Don. Can you hear me, Don? Would you turn it over and we'll see? Right. Its principle is that there are two wheels that roll on the surface. But since they're at right angles and kind of sharp edges, one will roll and the other slide in one direction. Each of these wheels controls through a potentiometer with a voltage output sampled by an 880 converter the numbers taken in by the computer at sample times as to what the horizontal and vertical components are to be of where it should put the tracking spot. And as the mouse moves over a surface, then each of those wheels either slides sideways without rolling or rolls an amount that very closely duplicates the particular component of horizontal or vertical in the net motion it makes. All right, if you take a mouse and move it through some closed trajectory back to exactly the same point, usually the tracking spot won't come back to exactly the same place it was on the screen. And for that sense, it wouldn't work well if you're trying to trace maps or other figures and diagrams. But the way we use it continuously and exclusively is to watch the screen and to follow it around, and we use this merely as a device to move that tracking spot, and your eye on the tracking spot, you really don't care whether it follows exactly this or not. In fact, we've had it at times where our tracking device, you had to move in an arc like that to make the tracking spot go on a horizontal line. And people adjusted to it and would go like that to go in a straight line and wouldn't even know that they were doing it. Other features of the mouse are that it stays put. I can lift it and replace it without having the spot change, so I can adjust where I want it for my comfort. And these control buttons on the top are used quite a bit, and I'll show you a little bit later how some of those are used. Now, the keyboard in the middle is essentially a standard typewriter keyboard, except for a few special keys out on the side. The computer knows it instantly when you hit one and makes an appropriate response. This device over here is unique to us, and we always have to justify and explain it. We'll do it in reverse order. We'll explain it first. It provides for you the one-hand equivalent of what you can do with a keyboard. There are 5 keys, and normally each finger sits on a key, and depressing any one key at a time produces a character. And any 2 keys at a time also. And in fact, any combination of depressing, of which there are 31 combinations. So Don soon learns and can type the message. I'd rather insert it. I, C, select, S, X. It'll offer you a character. If I hit W, it'll say delete word. The arrow moves back and forth to give me feedback. My tracking spot changes. That gives me feedback. Now it tells me, since it's an arrow that is armed, I can do something. We get a lot of feedback. Let me restore a view like this to show you. This is more normally the way we work with feedback up here. Where here I'm shown, it's not working. That's an echo register that normally gives you the last 6 characters that you use. Oops, not working. All right. The last 6 characters and left shifts continuously, so you can look up at any time and see what have I just struck. And that's very good feedback. Here are characters that show me the different viewing parameters, view specs. They get large at times at which I can hit single strokes that change those view parameters. And each of those means something to me, and their being large at particular times tells me I can hit very quick abbreviation for changing the view. So I can say, all right, I'd like to go to produce, but I'd like to go to produce, they get big, I'd like to say 1 branch only, and let me look just that low, and I see it. Oh, I can say, I'd like to see one line only. I can see it. So these ways I move around, the way I get feedback up here, the way I use both hands to coordinate to tell the computer what command and what short literals I want, are all carefully designed to go together to make the repertoire We've talked about the devices and now the nature of the dialogue, or the kind of feedback we get from the computer for each of the discrete character strokes and actions that the user goes through when he's executing a command. So that system is really represented to a user by the repertoire of commands he has, by the function of each of those commands, and by the control dialogue he has for each of them. So they all together go in and making a design, and to do it well, you have to be very careful about the nature of the functions in that repertoire and the natures of the way they're controlled. So we've developed a very special language for talking with extreme precision about these control, both the command functions and the control dialogue for them. And a little bit later, when we tell you about the programming, Jeff Rulison will bring in some special examples to you of the languages we've used actually to program at high level these functions and the control feedback that we get in these control dialogue. But that's what we're going to call the control meta language in there. Let's see how we're doing here. Okay, let's move our little marker to say we've now gotten control techniques by us, and let's talk about implementation of our online system. I put over here a reminder. When I jump to here, I want the view below it to unfold in a certain way, so I've just told myself, hit those parameter specs when this is large, and then execute. And yes, I see that underneath I am going to talk next about hardware design and then software design, and that's going to be done by Jeff Rulison from Menlo Park. Hardware design inviting me to jump on a link here. Aha. He told me there wasn't such a thing as a link under there, bringing me back to remembering how I should have gone through this. To go down another level in hardware design, there are two features we want to talk about here to bring out to you the way in which we've gotten the kind of responsiveness and flexibility we need in this instrumentation environment. So way off in Bill English's file, Bill is responsible for the design of all of our hardware. There's an outline he made of the way the controllers work for the I/O controlling. Now from this line to the right, things that we added to a conventional SDS 940 system. And this is the swapping drum. It's got two buses accessing to four 16K banks. The CPU has one bus and the peripheral equipment has another. And the good work of Project Genie at Berkeley, an ARPA project that evolved the 940 time-sharing hardware and software, produced a very neat priority system on this bus such that it can say, I'll defer my access to a given bank until the CPU doesn't want it. Or I'll defer it once or twice or three times, but then I really need it, so give me priority. And in that way, this bank can slip in many accesses to these while the CPU is hopping from bank to bank in its successive accesses. We've taken advantage of that to put all of our control out here, a large 96 million character Bryant disk for giving backup storage for ourselves, our two display systems, each of which drives 6 displays, and all of which are refreshed out of core, and the input controller which samples the keyboards, the key sets, the mice of each station about 15 times a second, and our printer and the ARPA network coupling here all come in through that same priority basis. So they can all be working full tilt, and we find that we get very low interference in CPU cycles being interrupted or interfered with, something like a ratio of maybe 1 to 1.5% here that it can't get when it wants to, and this might be running 50, 60, 70% of the available memory cycles that it can handle. All right. The input controller stuffs it into core without ever interfering with the CPU's process, and then just interrupts the time-sharing system if there's something new and says, hey, take care of this user. And the display system reads out of core in from a tree structure-like set of links to cycle itself automatically and take all that material, output it to the display something like 15 times a second without any interference from CPU requirements. All right. So that system has allowed us to have one time-sharing computer take care of a lot of stations. Let me talk to you about the display systems, the other aspect of the things that we've built on here that are slightly unusual. All right, for that I'd like to switch to Menlo Park and get a view from a camera there and actually looking at the hardware. So these are the units that develop the displays. The computer constructs it right on a small high-resolution CRT, which you're focusing in on right now. And in fact, that's the CRT whose camera on the right, looking at it, is generating the text view that's being piped down here on my console. So as those are faded in and out between the two, you can just sort of compare them. So that's very nice. There's my mouse moving around in Menlo Park, my tracking spot. So our displays work with those being watched by commercial cameras. Look at my black bug. Commercial TV cameras, 875 line scanning rates, so they're fairly high resolution. Look at that. From there on out to the display station, the standard video microwave system. If we back up the camera shot a little bit, we'll see that we have a whole rack full of equipment here, serving 12 of them, but you'll notice quite a lack of cameras mounted on. We seem to have stolen them all for this show. So we only have several consoles that work right now because the cameras are mounted to give you these different special views. All right, there are quite a few advantages. We use this particular display system hardware technique pretty much as an expediency for an experimental system we had to build. We originally were going to build storage tube displays into here, but we couldn't get them delivered a year and a half ago when we really had to firm up our design. So we, as an expediency, went to this. RAND has been developing some very nice video stuff. They were kind enough to show us how these controllers and all would work with video. So we went ahead with this very simple brute force way of having the video signal generated by looking at a small CRT. Well, it turns out that that little CRT, its incremental cost, the video camera, the controller, and a monitor total about $5,500, which is cheaper than most fairly good resolution random deflection display monitors would be. So we come out well on the price of the hardware. Turns out that also that the cathode of the camera tube in just black and white usage like this, you can back off the scanning current of it so that it's a sticky cathode, so that actually it doesn't erase the image on it by each sweep. It may take 3 or 4 scans. And so with something like a 15 cycle a second refresh rate on those CRTs, the camera, the one that's generating this as well as the one we looked at it with a few minutes ago, have short-term storage in there. It's quite different from long persistence, but gives us the flicker-free display here for quite a flickery display there. This lets us use that display generation hardware for 3 to 4 times as many display stations as otherwise. You'll notice if we get just the text alone that there's a small effect by that bug smearing, but it's not that bad. And that comes from the memory in the Vidicon tube. Okay, so much for that. I'd like now to have us bring in Jeff Rulifson from Menlo Park, and we'll switch to his console. He's sitting at one just like this, been working independently. Hi, Jeff.
Oh.
We're not hearing you very well.
Oh, you're not hearing me? How about now?
That's fine.
Okay.
All right. I'm sorry you can't see everybody here, but I can't very well either because of the lights. So we're about even.
Okay.
I'd like you to talk to them about the way the special languages have helped in making flexible design and study available for us of the user features, the functions and the repertoire of the commands, as well as the control dialog for them. And then also, it'd be an interesting example here because programmers you programmers are the ones who most intensely found use for working online as we're building up. Show them how you structured your system guide. Okay?
Okay. I think we can do that. We can get sort of a good feeling for the way the whole system is put together by looking through the system guide. The file is one that system programmers sort of put together, help them get around. NLS right now is getting to be a fairly large program. It's not huge by a lot of standards, but it's getting pretty big. This picture in our system guide file is a picture of the overlay structure. Our overlays are page sizes, so they're not too big in the 940, but each label in this picture names a code file, and each one is 3 to 20 pages long. I mean, 20 text pages if you printed them out. Just to sort of show how you can use a file like this to move around in the code, and also how the code is put together. As I said, each label in the picture is the name of an overlay, which is also the name of that file, but it also happens to be the name of a statement in this file. By selecting one of these pictures and moving there, I was going to do something for you to let you see better. What did I do?
Yeah,
we go back to the origin and start over again.
Bring back all the parameters.
There. Now let me move out. From the picture, I can move to a little section in this file, which is an area that system programmers leave around notes for each other. There's nothing much interesting here. A little bit about the documentation and the patch space that's left. Right from this spot, I can actually move out to the file. Suppose that I were going out in that control meta language Doug was talking about and just try to see, for example, the routines used in the delete word or move word. Let's go look at move word construct. I just select this link, and here is the file. This file is written in one of these many special languages that we've designed. So I just move down through it, find the move commands. Move, let's look here for move word.
You want to point out how you know it's move word?
Yeah, well, I was just going to look at that, Doug. As I was stepping down through that, I was sort of not only moving through the file, but the structure of the code is rigged in such a way that it's a description of a finite state machine. And so I was following the characters a person would type to execute that command. Down here underneath it, I see that the routine is QMW over in the overlay text edit. So let's go back to that other file. Move back to our picture again and find where overlay text edit is. It's right down here, so we'll go and sort of move down through that one. The text edit overlay illustrates a lot of the different kinds of things that we've done. This file has two major kinds of code in it. First one is many of these different special languages that we've built up. See, I'm trying to find QMW. That's right. It's down here someplace. There we go. Let's see. Oh yeah, it's the two kinds of code. This is still the kind from the other file, but the QMW routine, the first subroutine, the second subroutine that it calls, which is sort of interesting, is move word, or word delimiter, I'm sorry. This routine is written in our content analysis language, and it takes a text string and finds the definition of a word. It looks out for punctuation, and it finds any special blanks around it, and finds pointers that describe that word. Another interesting one is the next subroutine here. If we look at it, it's in another special language that we've built up. It takes the pointers left over from the delimiter routine and the text in the file and reconstructs the statement after the edit's been done. Let's see. Where was I in this file? The other portion of the file is written in the language that we call MOL. It stands for Machine-Oriented Language. The MOL is in a sense, it's a high-level language in that it has phrase structure and good control constructs like if statements and while statements, but it's also very, very close to machine language, 940 machine language. People talk about the actual registers of the machine, and you talk about doing indirect addressing. This language has helped us write the kind of fast, tight code that we want, that we have to have to operate in the time-sharing system, and at the same time, it's given us a lot of flexibility. It's also, the phrase structure of the MOL is designed to sort of mesh with the block structure of NLS. So here I've got a while statement. To see what's in that while statement, I can move down and see its three statements, which is an if statement. The if statement is a single if statement, which has an if and an else part. And that whole block opens up to all of that. So by using the MOL like this, I'm able to move around very quickly in my MOL files. Also able to sort of zoom in and out of things. One of the, besides the sort of program organizational benefits that we get from designing all the special purpose languages, we've been able to design the syntax of these languages so that they fit with our linking structure and the conventions that we've set up and the aids we've built to help us in NLS itself to move around between them. One of the ways we've managed to implement all of these languages is by designing a compiler which we call TreeMeta. All of our compilers are written in TreeMeta. I'd like to add that we're very thankful to some people at Systems Development Corporation for helping us get started on a lot of the notions in TreeMeta. Erwin Book and Val Shorey were just invaluable in helping us get started. By having all of our compilers written in a higher level language themselves, we've been able to change them all the time. So we're not only able to quickly modify the syntax of the control language for NLS itself, or the meanings of the commands by working in our high-level language, but we're also able to go in and just change the compilers as quickly as we have to accommodate all sorts of new hardware features and experimenting that we do like that. So in a system guide file, there were three sections. The first one served this program structure, and the picture and the fast links we looked at were sort of aids that the system programmers have built up to just move back and forth and leave notes. Second section here is on retrieval. I think I'll let that go for a while right now. The third section, more notes that programmers leave around about bugs, things that are wrong with our system right now. I got my blank line off. How did I? Well, anyway, one of the interesting things that NLS does, just an advantage of being online, is it keeps track of who you are and what you're doing all the time. So on these statements, on every statement that you write, it keeps track of who you are and when you did it. So not only can people leave notes around for each other, but sort of automated into how there's an automated aid here that tells us who did it and when they did it. I can set up search patterns. I think these will probably be talked about later. So that sort of summarizes what the thing looks like and how it's put together. Is there anything that I haven't talked about, Doug, that we were supposed to bring up?
I think you've
looking at my notes right here.
You're doing very well, Jeff.
Thanks.
You ought to see yourself with a 15-foot face.
I'd like to.
Great.
I guess I'll just turn it back to you then. I might add that people want to come up to our room sometime. We're more than anxious to talk to people about languages and meta-compilers and all of the games that system programmers like to play. So I think I'll sort of turn it back with that.
Well, Jeff, how about going back to that place in the control meta language where you start down the dialogue protocol a person would use?
Okay. right over here in main control.
Yeah. And off to another file where we're looking at real code now. And there's a branch of it down there.
Yeah. These top branches are all subroutines that are pretty meaningless, and it's WC means what case, and it's what's the person going to ask for.
So open that one level down now. Right. Now, all those things in parentheses that in NLS are the names of those statements are actually in the programming language that works here, the way it's identified, that's the character a user hits. If he hits a D, for instance.
A D here for delete?
Right there. All right. If he hits a D, that line tells you what the response is supposed to be. The computer's supposed to display certain material on the top of the screen. And then it's supposed to wait until the user does the next thing. Why don't you trim it to one line?
Yeah, I was going to do that. Why doesn't my branch only work? Oh, that's all that branch. Okay.
Hit EBT.
Well,
it's easy.
Okay.
I don't want to insult you by saying that it's easy to get a new view. Down there to say, all right, then if he's hit a D and it sets up what it says there, you can up one level below it, and that's the next block down in this special language, and you see, well, if after the D he hits something else like a W, it goes on from there to say what it is the computer's supposed to do in response. So this language here in its hierarchical structure, resembling the branching tree of choices user makes, specifying at every point what the computer does in feedback and the optional choices, and down in the end then specifying the actual function, like deleting a word. What's a word? And what do you mean by delete? And for what's a word, that's specified off in the subroutine he showed you in a special language to find in there what a word is. And it doesn't take a lot of programming skill to learn how to read these languages because they're at the concept level almost where the user wants to work. And so for us in our experimental environment, our users are beginning to learn this so that we can look at that to find out how the system works and not at somebody's English text translation, unspecific though maybe. Well, Jeff, you did a great presentation, especially the last part.
Thank you.
Thanks very much. We'll come back now and I'll get my prop with my text and we'll go on to talk about some of the, oh, no, wrong text. Right day. Thank you very much. Well, remember that we were talking about hardware and software and implementation, and if we go all the way back, we see that we've finished control implementations, control techniques, and the implementation, and let's move our little marker down here to keep track of where we are. And we're ready now. I'd like to run through some of the ways in which we actually have used this. The programming itself represents a very good example for me, where following from the basic philosophy that concepts come in structure, and you'd like to structure your database, your information base that way, and have a tool at getting around it, I think that the way we've got our records for our programming organized, and then the special languages, using the hierarchy, using the names of places in there as labels of statements, so both NLS treats them as a name it can jump to. The compiler that compiles those files we were looking at treats those as the labels for those subroutines and procedures. It all makes a very nice way to study and integrate, and it's very powerful, exciting sort of thing to show. I hope people do come up to our open house and look at that. Let me go down here and open up under usage and say first some application examples. User documentation is a straightforward sort of use. If you were a user here and came and sat down early, you'd want to get familiar with this file. Let's go look. Dave Kasros has written a user's guide. So down the hall in Dave Kasros' office, in his drawer, pulling out the file, we go, and there you see it. The top view of it with the sort of the outline. But I'm interested in just showing this view very quickly. You want to find out the definitions of a lot of terms. Here's sort of a glossary. Well, let's do the thing called freeze a statement, and then open and say, put that at the top. And lo and behold, that statement now is going to be frozen in our display scanning windows from the dotted line down. And then we know about names and jumping to name, and so we can say, what's a bug? Oh, down here tells you what a bug is. I see. Well, let's see. What's a level? Select level. Tells you what level is. What's a mouse? That's fun to look at. There's a mouse. You can just point. So you can sit here and point to successive terms, and it goes there. The scanning window goes there. The frozen glossary stays, and you can see the definitions. Very nice. And some of the definitions you can recognize terms here. That's an odd one. Maybe that's a name. Let's just see. Oh, sure enough. It's a sketch showing the mouse and the mouse buttons. Very nice to have documentation like this, and you as a user could sit down and early find your way around in this to find the definitions, descriptions, procedures for commands, and all like that. So let me go back to my guide and say, the next thing, you want to study or modify papers. All right, it happens to be that we wrote a paper for these proceedings. It's in the files. There it is, top level. Gee, it's interesting to study something like that. What does it have to say about user systems? Go to there, open up a level. I only want to see that branch. Oh, what about file studying? Open that up. Oh, specifications of form of view. What about that? Let's just open it all. Now I can read it. Gee, that's an interesting way to study. This material, incidentally, was organized for printing and printed out. And it's from this file directly we printed it out on the form we sent to the printers. And these things up in here, these three letters and equals, are special directives we embed in our text, so when the output processor does it, it puts in things like headers. Like this says, make the header on every page be DC Engelbart abstract. That's the prescribed form. The number between lines, double space it. All these others have characteristics. You get right justification, page numbers, all kinds of control on there. All right, so much for paper writing. Well, print out directives, I feel a little rushed for time. I'm going to skip that. That can show you a guide of all the directives for printing out. If you were a user, you'd want to go to that so you can have links to it. Joint file usage is something that is very powerful here. I went off to a file that we were working on as we were getting ready, the early parts of this presentation. And it was a message, it was something that three of us used a lot between us to coordinate the planning, task, contingency plans, the special needs in NLS for the fall joint, things like that. We developed a message technique so we could leave messages for each other. Under there are usage conventions, and let me just tell you about that. Underneath here, we direct messages to each other that we can unfold and see. But many times, you didn't want direct messages as much as you just like to go through and leave a message for somebody. So we worked out that the conventions would be, where's an example? The convention we're going to use is that we would send a message to Guy. If I wanted to send Bill English, WKE, a message, I would put that in the file, WKE from DCE, with that pound sign in between. So any statement that's marked like that means there's a message to him from me. If I want to, I can say was also for Dave Evans, like that. So that's from me to both of them. All right, we have this thing we call a content analyzer, Jeff mentioned briefly, in which we can write expressions in a language. Let's just come down here and look. Here's a little expression in a special language that means I'm going to look for Mr. XXX, a message from him. All right, what if I say I want that XXX to be DCE? That says someplace in there I want to find that pound sign and DCE. So we've got a little compiler. We say from there, compile it. Comes back and says I did it okay. And now I can say, all right, only show me the statements that passed the test, that someplace in them they have that string. There they are. So in every one of those, that's from DCE, DCE. You go down there and look for it. How'd this one get here? This is to anybody from DCE. Then I can say, well, turn off that filter. How about for so-and-so? So I can say, all right, this is for WKE, a message for Bill. The rest of this pattern here says it's got to be followed by any number of commas and letter triplets, but eventually by a pound sign, or it doesn't go. Well, let's compile that and see. Okay, it passed the test. All right. There's for WKE for him, and a dummy. Okay, so, oh, it wasn't through searching. The thing about a time-sharing computer is that once in a while it gets being asked for business from other places, and if the response we want runs into a fair amount of computation, we run into other people who will bump us off to do it, and so sometimes it'll take a while to filter through all the patterns. But that content analyzer sometimes now if I'm disabled slightly because this seems to be hung up in the wrong place, I'll have to run by the keyboard, and that's a real bag. If you know, I'm so used to working with one hand and this that I can hardly remember what to do on the keyboard. Anyway, I want to go back to the file. The other guys at the other end of the time-sharing system are going to go in and see why, and I hope some hardware guys are too. I want to bring in that file. What kind of categories we have set up for these people? Well, that means roles they're going to play, and that they can play, and what their open house duty or the duty back in Menlo Park during those 2 days are going to be. This is a terrible. So under here in the roles, we have quite a few roles. Somebody play just coordinating, that knows NLS software, that knows the time-sharing software, that knows the display hardware, the transceiver hardware, user references. We need to cover those at each session. And we also say there are these different sessions available. Well, let's jump down. God, how do I jump around? Jump down and look at this duty roster again, where we look underneath each guy and we realize we put a bunch of these code terms under there to say, okay, that's Menlo Park Tuesday morning, open house Tuesday evening, Menlo Park Wednesday morning. He knows NLS and time-sharing system. So these are the categories. And now I can go back and using that content analyzer sort of thing, I can set myself up fairly nicely with special patterns. Like I can say, here's a pattern all set up, so it'll say, I want to see those people that are open house Tuesday evening. So I just can compile. Hey, it's working now. I compile that successfully. I say, all right, let's see it. So it does. It says, open head Tuesday evenings, open house Tuesday evenings. Andrews, Evans, open head. You'll have to forgive me for getting slightly rattled when this thing started giving me trouble. All right, these 4 people are on Tuesday evenings. That's very handy. If I wanted to, I can go to a view that only shows me what category I was filtering out. And I can use another thing I call markers. I haven't told you about lately before. You've noticed that many times when I'm doing something to operate on some entity, I use this bug to point directly. Well, it so happens we have a feature we call marker, such that any place in a given file I can place a marker on a character and give it up to a 3-letter name. Then at any time in any command where it's appropriate to point and push this right-hand button to say select, I can hold the button down and enter that name and let the button up, and instead of it taking the character I'm pointing at with this bug, it takes the character for an operand that I had named, that I put that marker on and named. So off someplace I've got markers on patterns already set up for OTE, open house Tuesday evening and such. So I can say execute compiler from here, and I can type in open house Wednesday afternoon, OWA, and say execute it. It says I did. I say, all right, let's see what you've got. Oh, open house Wednesday afternoon. These are the people that are going to be there. Oh, what about open house Wednesday or Tuesday evening? the OTE, execute. Open house Tuesday evening. So these kind of pattern matchers and markers and freezing statements and jumping on things give us a great deal of power jumping around and moving, jumping around and studying. Right. Okay. All right. There are other things to show here. I forgot that it didn't need to freeze here. All right. Design documentation for our hardware and system analysis records. I'll just jump very quickly to that, just to show you that we use the same kind of structured stuff in the design of our hardware, where here is the design of a buffer register, and these are the different components labeled by comments in a language that's going to digest this file and produce a wiring list. We can open up another level and see that underneath of these are all the logical equations. We can come in just as quickly as anything, search down, search for different patterns, jump on links, modify them, put them out, recompile them, we're back. All right, I think I'll skip the rest of these because time is crowding us. And I'd like to go to a little sequence here that is really a very important one. Now you've seen most of the way through here how this serves as a very powerful tool for an individual to work when he's studying, doing his planning, designing, debugging, documenting. But we also saw through the medium of leaving messages for each other and filtering them that people can collaborate quite well over a period of time by working on joint files. In fact, you can have a joint file and go leave a message and get a response in a matter of minutes because they're all available instantly by anybody from one of these terminals. But there's another degree of collaboration which is very important and which we're just going to be setting up in the next few months the hardware to do computer aid. But here we're going to set it up with a little bit of people aid too. So I'm going to establish a collaborative mode between me and another terminal. Bill Paxton's at a terminal back at SRI, and the first thing I do to do that, of course, would be say, hey, I'm going to, to call this command, we have to go into the executive mode and set executivity to a special level. Oops. And then continue with NLS. So that free demonstration of some of the versatility. All right, special command. I'd like to link to Bill, and I don't know what his terminal is right now, so I have to ask for somebody to connect me to him audibly. So Bill, will you come in through this intercom?
Hello, Doug.
Hi. I need to know what terminal you're on, Bill.
13.
Okay. I'd like to have him see my text. And so this special thing, if I label 13, will switch over. So in his display, he sees my text. So I'll execute it. And sure enough, it does. But what's that running around? Well, if he's looking at my text, he'd like to have something to say about it. So we put on a marker, a tracking spot that he controls. So he's sitting there in Menlo Park looking at this text, and he can point to it. But we've carefully reserved for me the right to control and operate on this. So my bug is more powerful than yours. But we can have an argument. Yeah. That's what they call a bug fight. So, all right. So in case you haven't been listening, Bill, we've been going through lots of examples and setting up in collaboration here so that we can go on into information retrieval. And we've set up now audio coupling, and then we're both looking at the same display, and that'd be very handy to work. We can talk to each other and point, and maybe later I could hand you the chalk on this blackboard, like saying, here, you control it. But let's stay this mode now and add another feature that hardware-wise is available through the kind of display we have. I'd like to see you while I'm working on it. So before I can do that, I'd have to set up my display in a certain way. Set it up so I see it over like that. That leaves a corner up there, and I say, now computer, do the automatic switching that'll bring in a camera picture from the camera mounted on his console, such as the camera mounted on mine is. Hi, Bill. That's great. Now we're connected audio, you can see my work, you can point at it, and I can see your face, and we can talk. So let's do some collaborating. You're silent. Oh.
What do you want me to say?
Yeah. There's nobody here but a large audience, Bill.
All right.
All right. So let's go talk about information retrieval. And there are a lot of things I've been showing them and jumping around and finding your way, relating back to the portrayal I gave about NLS as an instrument on complex data structures. It shows them how we can get around and find things. I showed them the content analyzers to help locate things locally. You had a file kind of classifying retrieval stuff. Why don't we switch to it? Yeah, good. Hey, I can't point.
Oh, okay. You on 13 or 12?
12.
You're on 12, okay.
You had executively set.
There you go.
Where am I? There.
There you are.
Great. All right. Now, talking about hot retrieval. That's, you're going to have to defend that.
You going to give it to me?
Yep.
Oh, okay. We've been talking about retrieval all afternoon, really. That's one of the main things you're involved in doing. Every time you're changing a view, you're doing retrieval, really. I've broken it up here into two main categories. The first where you have a known destination, the second where the destination is unknown. These really present two different problems, and there are different commands in the system, naturally, to take care of these two different things. Let's open this up, take a look at what we have under here. Oops.
Good.
Got both direct and indirect. In the first, where you're making an explicit specification, and the second with an implicit. Explain what I mean by this. In the first case, you're actually able to point at what you want at the information you're trying to retrieve and move it into view. With the jump to identity command, you're able to point at it either by the cursor or by using a pointer, as you've shown. Jump to name, jump to link. Again, you're explicitly specifying by giving the name or having the name occur in the text. For implicit specification, by this I mean using information that's been stored by the system in order to specify where you want to go. In the first case, the information has been stored in the form of a memory of what you've been doing recently, so that you're able to say, jump to the view that I just previously had. So I can say jump return, and it'll take me back to the view, or jump return, and I go to the view that I had just before that, or I can say jump ahead and move back down again. Jumps referring to the structure. By this I mean the structure of the file, so that you're able to say, take me to the successor of the statement I'm pointing at, or to the head of this branch. Things like that. Content analysis, we've covered quite thoroughly. Let's go on to the other main branch of retrieval that we're talking about. Here again, I've broken it into direct and indirect. This is the case where the destination is unknown. By this I mean you don't know where the information is, but you're able to describe it, or you know enough about it that you can find it either in a hierarchy or by describing it with keywords. By the use of a hierarchy here, I mean working down through the hierarchical structure of the file, making use of the categorization that's built into the file. This we've seen several times. Let's, just as another example to really make this clear, we've talked about the desire to get hard copy of a file, wanting to get something printed out. There's quite a large system that takes care of giving making a file for hard copy. You're able to specify how you want the hard copy to look by giving various directives. one of the things you might want would be Roman numeral page numbers. So let's go off to a directive file and see what the directive is to get Roman numeral page numbers. I'm into the file now. Here's the first level of the hierarchy. Let's open up page formatting. We look, we want page numbering, so we'll open that up. We find, yes, here it is, Roman numerals. We find out the directive. Yep, your bug's right on it already, Doug. Here's the directive we want. So we've worked down quite a way into a hierarchy, as you can see. This is quite a nice way to be able to very quickly find what you're after. Let's go back to the previous file now. Look at this last type. By keywords and associative reordering, I mean the use of terms from a specified vocabulary to describe what it is that you're after. Perhaps the best way to show this would be just to draw a little picture. The keywords can be selected from a list. We'll put the list over here. You can have any number of keywords. I'll just put down that just to give an idea of what it is. And then we also, oops, I spelled that one wrong.
Need any help?
Yeah, how do you spell catalog? There it is. Is that close enough? There will be several items in the catalog. What we want to do then is select things out of this catalog.
What do the R's stand for?
Those are the numbers that are used just like serial numbers. That's my own Dewey Decimal System.
Oh, you mean reference 3, reference N, something?
All right, right.
Oh, okay.
And then the K, I guess, would be keyword, huh? How's that?
That's fine.
Each keyword then will point to various items in the catalog. So the first keyword may point to those, and then the nth keyword will point to other ones. And there will be cases where they both point to the same one. When I select a keyword, I'm specifying that all of the items in the catalog that it refers to will be pulled out and given to me. And in the cases where I've selected several keywords that refer to one particular item, that item will be given special preference and will be put at the head of a list. And then with that list of items from the catalog, I'll be able to use the other forms of retrieval and jump off and look at the items and then continue the exploration. Okay, let's actually go ahead and do that. I'll go back to the systems guide file. We mentioned earlier that there is a large part of that that's concerned with finding things. This is our documentation index for the NLS system. It's broken into the two parts, the catalog and the list of keywords. The catalog is just a long list that goes off the screen that contains links off to the various items in the documentation. There's actually an entry here for each procedure in the system.
Hey, this is the same file that Jeff was looking at, isn't it?
Right. Let me
system guide for programmers to find things in.
There's your same picture. Let me get down here. There we are. See, the first part is the catalog. The second part contains the list of keywords. Let's open that up. They're again categorized into the various categories that you would want to use to describe what you're after. Let's look at file handling and open that up. Here we have the list of keywords that we can use to describe things that have to do with file handling.
The things in parentheses, the names of those are the keywords?
This is just a name that's used to keep track of it. It can be, the keyword can be referenced from any place in the text by this name. Then there's a phrase following that that's a little more descriptive that tells what it's about. Then following that, there's a list of the items in the catalog that are referred to by that keyword.
Yeah, you're only looking at one line for each statement, so you only see the first few. Right.
So now I'm able to actually select the keywords that I want to use to describe what I'm interested in. I can do that just by pointing at it. Then it writes the word up here, and another command to accept it. I can just accept file control, and I've already accepted file referencing. I'm able to, I'm also, we still on?
Yes, we hear you.
So somebody hung up on us.
How do you say go ahead with a mouse?
We're on?
Yes.
Doug, you back? Doug can't hear yet? Oh, okay. So I've selected several keywords here. I can go ahead and give particular keywords greater weight. The weighting refers to how important that keyword is in describing what I'm after. So I can give this one a weight of 2, whereas this one previously will just have a weight of 1. That means that the items that are referred to by this keyword will occur earlier in the selection when we're finished. Okay, let's go ahead now and say keyword execute. This will go off and get the items out of the catalog and reorder them. And there we have the results. Now I can use these to jump to various places in the file. I'm still in the systems file. The item here is the name of the utility. So I can jump and get the information about that utility in the file, find out the various things about it, go back to the previous view, and now if I want to go off and get the information, I just do a jump to link on this. And here I have the documentation on that particular procedure. After looking at that, I can go back again and now I'm set up again to go and continue looking. I can look at the next item and here I've got the results on that. So I can continue to proceed in this way, looking at the various documentation and going back and continuing to explore, or I can re-specify the search parameters and look at new keywords. Well, Doug, I don't know if you survived through that. We had the operator, the telephone company hung up on us, I think, halfway through. Are you still back on?
Yeah, I guess we better come back, and I'm sorry I can't say goodbye to Bill.
Oh, I can hear you now.
Oh, great.
There you go. You've been talking all this time?
I saw when you leaned over and hung up the phone for a while, so I couldn't interrupt you. All right. Well, thanks. I'm sorry that we're pushed when we're trying to describe each of the features in this system. This particular one, the keyword, is very powerful and could very well warrant a whole session or a whole paper on itself, because it gives us the power of keyword descriptor kind of organization, but with the added feature of giving weights to the keywords so the results of the search, as you see right here, are ordered so that this one ended up meeting the most requirements and adding the most weight, and down here could be one that only associated with one of the descriptors and the lowest weight one at that. So you have an ordered list that's probably relevance. And then right with this, all the links. Use that as a link to go off to the file to find it. This is a directory of a set of procedures. So here's here's a list of procedures for those keywords he chose that all describe certain things about file handling. And this will take you off in the actual source code. Looks like Don Andrews wrote them all in his files. The name of the place in his files, and the views that you should open up so that when you follow this on a jump to link, you just see bingo, the overall view of that procedure. And then as he pointed out, instead of saying jump to link, you can jump to a name within this file where these things have descriptive material about that too. So I think for the software guide, it's very powerful. And thanks very much, Bill. We'll
very good,
out.
Doug.
And the combination of of techniques for getting around inside of the structured software files, and the way in which they're organized and the way in which the special purpose languages we've developed fit with the structure we've used, really give a very powerful set of techniques. And I really enjoin all of you who are software people and interested to come up and work your way through these, to have some of the software people during open house really show you what's what by taking you through that. Let me see my text and I'll see what I can skip so we can get through in the time we were supposed to, like 10 minutes ago. Let me go back to that view. And they're purposely making that dim so that I'll hurry. All right. Other things we're going to talk about very quickly are the range of activities underneath in our program. And I will just go very quickly through these then. A service system development and user system development to talk about those a bit only requires me to establish a distinction between those two kinds of a system. Really, we've taken to splitting the overall man-computer system into this dichotomy of these two systems, where the service system is what appears at the terminal. When I push this button, I get that response. When I do this, I get that. It's the repertoire of commands and the services that organization of software and hardware and sometimes people gives to me. The user system is what's beyond that. Given all that, what do I do with it? What kind of conventions for leaving messages and for using the content analyzer and for organizing our files, and how do we use the links and the keyword thing? User system there, and this is something that is kind of a new element in systems research that we're trying to establish well, so that we can integrate that kind of user system work where the people's methods, the concepts they use, the procedures, the skills, all are developed in coordination with the kinds of tools that they have. Within our bailiwick then, we also have an explicit activity we call management system work, where we are taking some project money and developing our own set of management tools to help us manage these 17 people and all these diverse activities in this complex system. And so we are beginning to develop some of those, and we'd be happy to talk to you about those during open house. And a forthcoming involvement is this ARPA computer network, the experimental network that's going to come into being in its first form in about a year and end up sometime later with some 20 experimental computers in a network. And they hope to be able to transmit across the country with bandwidths of something like 20 kilobits per second, delay times of less than 1/10 of a second, which would be enough so that I could be running a system in Cambridge over the network and getting the same kind of response on a CRT. And it may be that people there, the next time we have a conference in Boston, I'll try this from there. And in that network, we're going to try to develop a special service to provide network information, relevant network information for people, for the kind of information that it takes to operate such a network. Who's got what services, what protocol do I use to get there, who's up to date, how much, where's the user's guide, where can I find the paper that describes this system that so-and-so offers. And that's going to be a very interesting challenge for us to utilize our tools for organizing and retrieving information. And the last thing here is just a little comment about, after all of this, what's the product that we're providing in this research? Well, we're providing a sample augmentation system, the one we use. And not only that, it's an augmentation system that's provided to augment computer system development. And beyond that, we also are hoping that we're developing quite a few design principles for developing augmentation systems. And these, I hope, are transferable things. Let me I'd like to close and give you some description of the support we've gotten from the different people to produce this and to acknowledge that. And back in Menlo Park, we've got quite a team of people surrounded by quite a bit of equipment that have been busy listening to us and trying to control and switch. And these monitors are up here where all the displays went. The cameras went for some use, and the displays go here so that they can monitor the different signals and switch and send us what one we want. All right. And I particularly want to give appreciation to Bill English, who has not only designed all of the hardware, or been responsible for the hardware and software development that gives us our service system over these years, but in the last few months put together the considerable network of intercoms and video switching and controls and mixers, begged, borrowed, and stolen, that would provide this show to make it come off like that. To the supporting staff, Ed Vanderreet, Martin Hardy, Roger Bates, John Yarbrough, and Steve Favola, who have just worked very, very hard to make all of this work out technically. Dave Evans in coordinating this and in managing the open house we're going to have. Don Andrews, Jeff Rulison, Bill Paxton for preparing and presenting the material there. And beyond this too, we've gotten a great deal of support from SRI with general preparation support. Stuart Brand from Portola Institute has volunteered a good amount of time to help us. He was in that picture of people there. John Dusterberry of Ames Research Lab was very kind, saving our life by offering us a loan of this I-4 projector. That's the machine that's projecting this video image up on the screen. We were just bowled over when we found out what sort of a display we could provide of what we're doing, and we very much appreciate the loan of that. And Gene Warren from TNT Communications, who handled this, we retained him to come and help us be sure it worked, and he's just been a tremendous spark plug, running around fixing paging system for us and Tasker Instruments has done a lot extra work lately. The telephone company has done a great deal beyond what they needed to do too to fix this up once they found out what kind of a wild thing we're trying. And their video men yesterday were trying to help us out with phone circuits and all kinds of extra things. A very interesting credit to bring up next is Herman Miller Research Company. This is an affiliate of Herman Miller Furniture Company. And why are they connected with a computer show? Well, they've been bringing out some new office furnishings, and we've been very much interested in developing the whole environment for people working in a different way, and that means walls, desks, surfaces, console, and everything. We got so attracted to their line that they've started working to help us equip offices and study it like that. And one of their designers, Jack Kelly, came one day and spent a day working with us about our ideas about a control consoles as being separated from display consoles, and ended up making this on a chair that I can get up, move around, and sit down, and swivel, and rock, and lean back, and work very relaxed. So I think this is a very exciting stage. We've just gotten it. And in our open house, we have a full office that's equipped like this with this kind of a console that we're very excited about, and we invite you to come to. And without being formal, I'd like to really say that I'm backed up by a really very tremendous team of these 17 guys who have caught the spirit of putting on this show tremendously and have just done an overwhelming job about putting it all together, and about backing me all these years in this wild dream of doing this sort of thing. And they're all catching fire, and I want to just tell them all right now, I owe them a lot. And a very final credit goes to my wife and daughters who are out here, to whom I'd like to dedicate this whole presentation because of what they've put up with over these years, with a husband that dedicated in a monomaniacal way to something very wild. And so this whole presentation is dedicated to you 4 people there. And I thank all the rest of you very much for coming to the dedication ceremonies today.